Hello, this is Mike at GameFromScratch. Today we're going to do a quick hands-on with the Tilengine game engine. This is an open source 2D sprite style game engine that tries to go for that retro look. It tries to nail the aesthetic of the old Mode 7 graphics from the Super Nintendo, or I think it was Blast Processing, if I'm getting the name right, from the Sega hardware arcade boards of the time. And it does a very good job of it. Now, it's focused on sprite-style graphics, and it handles most of the stuff for you. It is cross-platform, it handles window creation, it handles input, including controllers, handles sprites, palettes, and it works with the tiled open-source map editor for bringing in those level files. It, however, does not have physics support, so you probably have to integrate something like Box into it, and it doesn't have audio support, so you have to bring your own audio library of some format. Now, the library itself is a very simple C library, as we'll see for a sec when we look at the GitHub source. But there are language bindings, as I said, for those various other programming languages. Today we're going to do our example in C# because it is the least documented of the four options. Now, it does come with a simple PDF about getting started, and it has setup guides for all the languages except for C#. And it's got a decent overview of what you need to get going. And then on top of that, there's also a fairly good API reference that shows how this thing works. And you can see the structure of it. Oh, I thought it was right here at the top. Where did the structure go? Somewhere. Anyways, it's built over top of, or layered over top of, the SDL graphics library. So if your platform has a C compiler, which is everything, and support SDL, which is basically everything as well, you can port this to it, probably without effort. Now, I've got a text-based version of this and all the source code available on GameFromScratch. I will link that in the comments down below. I will also link to that tutorial series on using the tiled map editor because it is pretty much the heart blood of this engine. So basically all your backgrounds, all your scenes, all your layers, etc. are created using tiled. So obviously that's an important piece in the workflow. So without further ado, let's actually take a jump in and look at the code. So this is hosted on GitHub. Now, one of the catches I found with this game engine is that it is not licensed. There is no license file. I have found no license terms. I have no idea what open source license this is issued under. Hopefully that is addressed by the developer at some point in the future, and I actually don't know. This library kind of made me realize I don't know what the default open source license is on a non-licensed project. So technically, if you're going to use this for something commercial, I would really, really suggest ratifying that before going too much further. It would be nice if he just slapped like the MIT license or something on there, but if he turns around and does something like slaps the GNU license on there, burn it with fire. I won't touch this thing with a 10-foot pole. So license is important. Let's hope that we hear something soon. That's a bit of an oversight. There should be a license in here. I may have missed it. It may be somewhere out there, and I just haven't found it, but as of so far, I have not found a source code license. Now, what we do have here is the code for it, and this guy is extremely simple. Oh, actually, that's the binaries. That's it. About 15 C files and header files, and that's it. It's a very streamlined, simple library. Now, the cool thing is, if you look up here, 15 days ago, blah, 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 down here, 7 days ago, etc. So the guy is doing active updates. This is very much a supported game engine at this point in time. Now, we've also, as I said earlier, got those bindings for C#, Java, Pascal, and Python. And just in a minute, we're going to look at actually using C#. We've got a decent number of samples here. Again, they're all very clean, simple C code. If you're looking at using this for C, that is where the predominant amount of your documentation actually is. If you're going to be working in C# like we are today, you're actually going to be divining most of the information, at least I did, from actually going into the tilengine.cs binding file. Because he's actually C-sharpified the bindings. It's not a one-to-one mapping, so he didn't use the same name, so the documentation doesn't match up. So there is some, okay, how do I create this? He's done from file instead of 4 or 5 functions in C to load something from file using pointers, etc. So there is a bit of a learning curve on getting the C# stuff going, and again, that's why I decided to do my example using C#. What else to cover here? Go back over here to the Tilengine. We've got, here are some of the examples and kind of stuff that focuses this engine on. You can see they're going for that, the classics of Mode 7, things like, F-Zero used to create it. If you're a bit younger than me, Mode 7 was often used to create 3D in 2D. So it's got a very unique historical sprite. And it could do historical importance to a lot of developers. And it could do neat things like barrel distortion, like you see right here. It's had fixed palette support. This guy's got some examples for doing shoot 'em ups, etc. So here, let me just show you. Here's one example. And there's full code for this. So this is one of those things. If you go over here to the examples, source samples, you will find, is it shooter? This guy's source code. So this example you're seeing running here is already available in source code. So now we've seen the engine. Last thing to look at is the documentation. There is a PDF file that is included in the download. I'll show you that in a second. Otherwise, there is a pretty solid API reference and some basic documentation. So your setup and run documentation is available here, but it's all pretty much one file. So here is your reference documentation. You know what? For the most part, it had what I needed when I needed it. So documentation is good enough. When you actually go ahead and download Tilengine, this is the contents of the archive, and then here you've got one more manual. So basically everything that was on GitHub plus this manual. It walks you through, getting started, installing. Very Linux focused in its approach, but you can easily get things up and going in Windows, no problem. There are no project files for Visual Studio, so if you actually know there's supposed to be a Visual Studio 2005 or something, they said. But if you had to build a C project just for compiling, there's almost no dependencies. It's dependent on SDL and that's it. So getting this guy up and built is a no-brainer. And I will show you how to do the Visual Studio project actually right now. So let's jump in and create. We're going to use some of the assets that they've actually included here from their samples to just create a simple side-scrolling sprite demonstration. So we're going to be using the Shadow of the Beast project files. I have no copyright claim on these. These are actually ripped from a game from the 90s. I don't know the legality of it. They are not mine. I am not rehosting them, but they are part of the Tilengine archive. So I'm reusing them myself. I'm assuming the developer of the original game won't care, but by no means do you have a commercial license to use any of these assets that are included as part of the Tilengine samples. So just be aware of that right up front. All right, so we need Visual Studio. Let's fire up. I'm using Visual Studio 2017 for now. No particular reason. I'm just enjoying it. All right. Let's resize you so that you fit my window. All right, so here we are. Let's go ahead and create a new project. C# console app. So Visual Studio C# console app. We'll go ahead and call this Tilengine demo, like so. All right, so here we are. We're going to erase all of this code eventually, but we have a couple dependencies. So first off, come up here, add existing item. And what we want to do is bring in the, so that's in my downloads folder. We need to bring in the C# bindings. Downloads, Tilengine, bindings, C#, and you just want tilengine.cs. All right, so we now have our bindings. We're good to go that way. Next up, we are going to need to do a little bit of, bringing stuff across. So first things first, I'm actually going to go ahead and build this guy. And the reason behind this is I just wanted to create the bin folders for us. Now, we're going to be using, I'm going to come over here and go to properties. I'm going to be doing a 64-bit build. So build and target platform x64. So that's the only thing we're really going to change from default. We'll shut that down and we'll do a build. All right, so our build is done. Click over here and let's open up the folder in Explorer. All right, perfect. So here is our newly created project file. What we want to do is just go into the bin folder and the debug, like so. And I want to go to my extracted archive. Oops, that's not it. That's not it. All right, that's it. Let's bring you over. All right, so this is the download version of Tilengine. All right, I'm screwing things up. Let me just come back over here again. I have too many Explorer windows open, and I'm confusing the hell out of myself. Shut you down. I want you, and I want Okay. All right. So this is our code, our generated code from Visual Studio, and this is tile. So what we want to do is go into our created bin folder. This is why I did a compile. So there's our code going to be running. And what we just want to do is go into bin, and we're going to be using all these SOTB assets. These are the various different files we're going to be loading. I'll explain them later on. Just copy them into the bin folder so that they're available to your code. And then the last thing you need to do is go on back and go into library, x64, and grab these two files. Now, I got x64 because when I chose to download it, I chose x64. So we go on back here to the download section, and you will see we actually have the option of x86 or x64. Now that is why I switched to the x64 build in .NET. Otherwise, you will get a runtime exception when you load it. Or you can bring in these binaries if you want to just run a 32-bit version. But do be aware that the version that you pick is important in this particular case. All right, so we now have our guy up and ready to go. Now it's just a matter of starting some code. So first things first, don't need any of that crap. What we do need tile engine. Now what you will find is I'm going to typo the hell out of that because I am going to do tile and then an engine every single time, which is very irritating. All right, so we are inside of our program. We are inside of our main. Everything is going to take place inside of our main. Very straightforward example for the most part. First thing we need to do is create an instance of the engine. So, and there's that tile engine thing I'm going to have to type way too many times, and I'm going to type it wrong. .engine.init. So what they've done is they've basically wrapped around a bunch of C-style functions into a C-sharpish way. In the C world, this would be TLN underscore window underscore init or something like that. A bunch of C functions. Now the resolution is virtualized, so we're creating this at a 320 by 240 resolution, which was a common resolution back in the day. We're going to create 16 sprites and 16 animations, even though we are using none of those. We need to create a window to render to. Again, window.create. You can pass in a bitmap, which is used for, I think, palleting information, etc. I'm not going to do any of that today. We're going to pass in tile engine. So you're going to notice I'm going to do that a lot. Window flags dot vsync. That's just vertical sync. It'll keep the flickering from happening, basically. So we now created a tiled engine. We created a window. And later, let's set the background color of our engine. Engine dot background color equals new color. This is an RGB value, so red, green, and blue channel. So give you a skyish blue green. And you know what? We're going to just go ahead and keep it simple for now. I'm going to just create this window and show it to you. So the last thing we need to do is actually have our render loop or our main loop. In order to create that, we do a while loop and we call window.process. Window.process is what gets the input, causes, basically it pulls for new input and handles, moves on to the next frame. So that is inside of this guy. So where we are right now, this is basically a game frame. So every frame of animation goes through. This is where we are. And one thing we're going to want to obviously do each frame is draw it. And that's just draw frame and frame plus plus. Now frame plus plus is the current frame, which we actually don't have. So let's keep it. All right. So that's it. That should be a working example. Let's go ahead and run that. So build works fine, run works fine. So there you go. We just created a blue window. Isn't that exciting? That's, we're part of the way there. Let's keep on going. Now this guy's pretty straightforward in code so far. The code's pretty simple. Like that's all that's required to get a window up on screen. Now one of the things you'll notice is it's doing resizing. I don't actually know the logic behind the resizing, but that was quite obviously not a 320 by 240 window. So you're using low-res PixArt size resolutions, but it's resampling them for modern sizes. So now that we actually have a window, let's do something with it. First things first, let's go ahead and add some backgrounds to it. This is where the tiled game editor comes in. And it is used for making tile sets and tile maps. Now, a tile set is a collection of tiles. Think of it as like an array of individual tiles. A tile is a 32 by 32, a 64 by 64, etc. Pixel graphic representation. Basically, you use tiles, a repeated set of tiles over and over again to create a tile map. So a tile set is a collection of individual tiles, often on a single image. So tile set, and we load that from file. This is one of those things we copied into the bin directory earlier. I will show you exactly what we were talking about. All right, I'll cut that one down so we don't get confused again. So one of the files we copied in was a TSX file. The other one was the TMX file. So tile set, tile map file. Those are both generated by the tiled map editor. And so we have that file. It should be local. It was called SOTB_BG.TSX. So load the tile set. Now var tile map equals tile map from file SOTB_BG.TMX, and we want the named layer 1. That again comes from the tiled map editor. You can have multiple layers in a map, so we're only using a single layer from this particular map that was labeled layer 1. All right, so now that we loaded our tile set and our tile map from memory or from disk, let's go ahead and create a layer. So basically, this is the game version of a layer of graphics that we're going to use those tiles for. So var layer equals new layer layer dot setup. So basically, this initializes it from there. You'll notice a tile set and tile map. And really, that's it. The last thing we're going to do, and I think this is actually redundant, but I'm going to do it anyways, is we're going to set the top left corner position of our layer for drawing, 0 and 0. Now you'll notice there 0 and 0 refers to the top left corner of the window, not the bottom left, as is common in OpenGL. So this took the DirectX approach of things, and this actually used to be the way that sprite graphics were done back in the day, so it makes sense to be consistent with the way that things used to be. All right, well, that should actually be enough. Let's go ahead and run and see what we've got now. Ta-da! So now we have our blue background and then a layer of tiles in a tile map being drawn in front of it. So we're one step closer to having an actual game. Now obviously you can have multiple layers. You can have a foreground layer, you can have a parallax background layer, and you could move the layer. So if you had this layer was just, so these clouds were on their own layer, you could easily have them in the background and have them moving separately. This is a process called parallax. So multiple layers are easily supported here. Okay, so we're one step closer. We have an actual graphic up on screen. That's cool. Now we want to get into a sprite. Now, sprites are basically created from sprite map. A sprite map is a sequence of files in a single image. Let me show you. So we go back here. We have a couple of things we are going to use here. First off, we're going to use a sprite sheet. I believe it's this guy right here, which is this PNG file. You can see it's just a sequence of sprites all on the same sheet. And then I believe this file is important. It's the mapping file. We're going to also use the sequence file. This is a simple text file that looks like this. And basically what you're saying is create an animation sequence called, so the sequence name is walk. This is a simple XML file. Call it walk. This is the speed, loop it forever, and use these frames in this order. So a very simple file format here for defining your various different animations. So that's what your sequence is. And if you had multiple animations, you would have multiple sequences within there. All right, so now that that's defined, let us jump in and actually use those files. So now we're going to get around to creating a sprite on screen. Okay, 1 second. All right, so switch on back. Now we need to create a sprite set. This is the collection of images that compose the sprite. Sprite set. And you're going to notice they went very consistent with their C#ism. So from file and SOTB. No extension on this one. Don't know why they went with that approach for it only. So that's your sprite set. Sequence pack. We saw the sequence file a second ago. SP equals sequence. I bet you can guess what this one's going to be. From file SOTB.SQL. X, like so. And finally, the sequence. So this is that individual animation frame or process that we defined within that sequence pack. We had that one sequence in it, was called walk. We're going to go ahead and get a reference to it from our sequence pack, find it by its name, like so. So that is essentially our animation. So now we have our sprite sheet, all our resources for our sprites anyways. Now we can go ahead and actually create a sprite. So just a sprite equals new sprite, like so. And now that we have our sprite, let's set it up. Same process as the layer, our sprite sheet, and we are doing nothing with it. Now we'll come back and look at that one in a second. So we're going to move our sprite along the x-axis only. So we'll start it at 15 pixels in from the left. And then finally sprite.set position and sprite x, and what did I do? 215. Remember, our resolution is 240, so we're just using pixel coordinates there, virtualized pixel coordinates. I should go ahead and run that now. And there is our sprite. Now, obviously, 215 is not going to work in this case for some reason. I thought that worked in my example. 320, 240. Oh, well. We'll just move that up slightly. All right. That works for me. All right, so we had our guy drawing bottom left-hand corner, 15 pixels in to the edge of his sprite, like so. Pretty much, we're good. Next thing up, we probably want to do some animation. That animation, we've already done most of the heavy lifting, so now we just need to create an animation object. Animation anim equals new animation, and animation dot set sprite animation. And we pass in 0, which is the index of our sprite within the animation, the sequence, which we just set up a moment ago, called walk, and loop, which is to say how many times do we want this sequence to run. And what I want it to do is run forever, so we pass in a value of 0, which basically means loop this sequence forever and ever and ever. And now let's go ahead and run that. And you're going to get a very 16-bit style looking animation going on. So we're closer to a game. Final thing we need to really do is add some animation. So I am just going to go into our main loop down here and change it up. So we just put an if here, window dot get input. If you've used SFML, it's actually very familiar to SFML. So input dot, and this virtualizes the right key and the right on the gamepad. So right, so, and we want to do sprite or sport x plus plus. And we will run that. So I press the right arrow and nothing happens because I didn't update the position. All right. All right, now with the actual position being updated, there you see our guy running across the screen and away to no man's land. Now let's put a little bit of logic in so that he can come backwards. And this is just going to require us to handle the left. Like so. Now, this is not going to give you the greatest result because what you're going to basically do is run this way and then moonwalk. And you don't want that. But we also don't actually have sprites for going the opposite direction. So a very common thing to do back in the day was to just flip the sprite. Now remember back here we did this tile flags of none? Well, there's a tile flag in there for flipping the sprite. So that's exactly what we're going to do. We're just going to change that tile flag. I'm going to have to do it both ways. Sprite.flags. So if we're going right, we want it to be none. File flags, tile flags dot none. But if we are going left, we want it to be sprite flags equals tile flags dot flip x. So So it means flip it along the x-axis. And as you saw, you can also do this up or down. And we go ahead and run it. So now, right arrows, and then left arrow, that's it. So really, we've got, throw some audio in there, throw some collision detection in there, but we've got the basics of a game done in like 10 minutes. So it's very straightforward, easy to use engine. The code you can see here, it's clean. It makes sense. It makes sense to me anyways. I don't think there's a lot of ambiguity here. This process varies quite a bit from using just the C code though. The bindings do take a much different approach. Now, one thing I should actually mention here is, right, so where's the end of my while loop? All right, so end of my while loop. Here, we're at the end of our main. What we should probably do, be good citizens and clean up. And that's it. So you have created a full-blown, deinit, sorry. Now, you have just, unwound all the damage you did, freed up all the memory you've got, which I guess technically it doesn't really matter because you were exiting your application anyways, but good housekeeping is always a good idea, and you should be aware that these are in fact managed resources. Unmanaged resources. So you need to get rid of your tile maps. You need to get rid of your tile sets. So if you're creating multiples and you get rid of them, you are leaking memory every time you forget to do this. So do be aware of that. It is an unmanaged C library underneath this guy. The C# memory manager will not automatically clear up memory for you for these objects, so you do need to get rid of them yourself. But that's it. That is, in a nutshell, the tiled game engine. It's Tilengine. It's free. It's open source. No idea what license. Available at tilengine.org. I will link that down below, along with the text version and the link to the map editor tutorial series. I hope you did find that useful. It's a cool little engine. Obviously it is for sprite graphics. Some people are getting really, really sick of sprite graphics, and I don't blame you. I'm kind of getting in the same boat. But this engine did it very well. Oh, and one thing I did not get into here, and this is where actually probably the biggest strength of this engine, is the sprite level effects. You can do a lot of, the raster effects that you had back in those days. It goes a long ways towards emulating them. So if you are trying to recreate the Mode 7 or the Genesis style sprite experience, there's a bunch of functionality in there for doing that. A bunch of things about for fixed palettes and that kind of stuff that I'm not touching on. I'm not trying to recreate a retro game myself, but there are all kinds of raster effects built in here that you should be aware of. Okay, so that was it. I hope you did find that useful. If you did, please do click like, share this with as many people as you think are interested in 2D games. And of course, we do all kinds of game development related stuff here. If you're interested in learning more, do please click that subscribe button. And I will see you all later. Goodbye.